Afternoon to you, or say good evening. So sit Ronald going to discuss some bit of chemistry about the topic and the subtopics which I chose in the subject of my study, and the subject is going to be chemistry. Now, the topic which I'm going to teach is called qualitative analysis. The subtopics are the physical appearance of the substances, action of heat on the substances, action of the reagents on the substances, and then the confirmatory tests of the substances. Then, if someone was asking me at the class level and the term of study, this topic is meant to be taught in the beginning of term 1 of senior theory. It's done so due to the reason that on the approach of senior 2, the end of term, they ended the term, oh sorry, here there is, they ended the term after covering the topic of acids, bases, and salts. So they have to start their next class with this topic, which is a continuation of the other topic, whereby a student is thereby knowing or also about the acids, bases, and the salts. So since the topic is all about the salts, the ions, the cations, the anions, and the student has just completed to know the absorbability, the action of heat, so the student is going to be able to learn this topic, and I assure you that students will understand it better. My class has a number of 30 students, and those 30 students are all in boarding section at St. Mary's High School, Muko. I'm assuming that's where I teach. So I have the academic characteristics of my students. So students have different characteristics, but all my learners, according to me, my learners are committed. They are committed. Let me try to make this clear. Let me try to make them clear. Let me use this. Now, they are committed in such a way, like when I'm teaching, they all pay their attention and they know what they want. When it's time for studying, they put everything aside and they start minding about what I'm going to teach. Self-discipline, being good learner, it requires making a study plan and sticking to it. So, not striking, yes, and sticking to it, even when there are such things you would rather be doing. So this is also one of the character of my students. They are self-disciplined, whereby I don't expect anyone to shout. I don't expect anyone to respond before my confirmation or before I accept him or her. Then the academic characteristic, which is the next one, is the focus. Learning to switch off all other distractions and give my subject their total attention also help my learners absorb what they are learning. What do I mean? It's like when we are at school, there are many distractions. You're teaching, people are moving, the skies are moving, the books. So that helps me, whereby all my students are aware of what I'm teaching. When I enter, they switch off all the distractions. Those students who are used to disturb their fellows when it's time for class are good enough when I'm in class, they don't do so. Next is the passion and the enthusiasm. Love your studies, knowledge is a better thing. Develop a passion for learning and your life will always be filled with wonder. What do they mean? What do I mean by that? So it's like if the students love what they are studying, that means even when the teacher is within the class, they will pay maximum attention in order to get to know what the teacher is saying. So those are academic characteristics of my students. Generally, my learners are at the level of the class, and the visual support they need is just small videos, pictures, and physical practicals. These visual materials will help them comparing the theory and those they will have watched in the materials, making them understand the concept of the topic. Besides, the topic is a practical topic whereby learners have to say everything they are taught in theory as how they are done practically. So it's like we are going to be looking at how the precipitates, what is the color of the cations, all of them, they have to see them, or watching them with their eyes in order for them to more understand the concept behind. Next is the beginning of my topic. What is qualitative analysis? Qualitative analysis is just a branch of chemistry that deals with the identification of elements or grouping of elements present in a given sample. It is the topic where one uses reagents to identify the ions. Those ions are grouped into the cations and anions present in a given sample. In order to know the ions, present, one will have to be knowing how different ions react with the reagents and what is observed in each case. For example, within this topic, we are going to see how someone can give you a certain substance minus letting you know what is within that substance. So that person, he or she will require you to tell him what is in the substance. How are you going to do it? By using certain reagents which can confirm the presence of some. So how are you going to be able to confirm? That's when you know how the reagents react and what is observed in each case. Now, next, my small subtopic is the physical appearance of substances. Those substances which we are going to be seeing. If you're given a substance and you have to first see how does it look like. So this small table is going to be showing when you see this, what do you deduct, what do you conclude with. So if someone sees, or if someone is given a white substance, if not substance, it can be colorless liquid, anything white colorless, that person must suspect magnesium, ammonium. This is magnesium, ammonium, zinc, aluminium, lead, calcium suspected present. What they should know is when we are in qualitative analysis, especially in practicals, we don't write the names, we write the ions, as you see I've done. So whenever you see anything blue, a blue solid, a blue substance, or a blue solution, you must suspect copper, because at your level, we only study about copper. Anything green, that is iron 2 and copper 2. You suspect both 2. Why do we include copper again? Copper, we see some some substances of copper, or like copper to carbonate, is copper to carbonate appears to be green when it is in powder form. So, and yet the any substance or any solid containing iron 2 is also appearing to be green. So when you see green, don't just say iron 2. You have to suspect even copper 2, because when it is in solid form, it appears as a green substance. Let's move to the next one. Brown solid stroke solution. Brown solid stroke solution. Iron is iron 3 suspected present. It's only thing which we have brown at your level. Now, let's move to the next slide. These are the images of the physical property, for the physical appearance. You're seeing the first one is copper to carbonate. So this is how it looks like. This one is copper to nitrate. This is how it looks like. So you see, you're seeing like copper to carbonate here. For it is green. You're seeing something which is pale green, but copper to nitrate is blue. So that's why I've said, when you see green, you also suspect copper. You see iron here. Iron is also green. Look at the color of iron and the color of copper. You're seeing they resemble each other. This is iron 2 compound. Iron 2 compounds, I've said they are brown. You're seeing it. This is aluminum nitrate, which is white. This is zinc 2 nitrate, which is also white. Magnesium nitrate, which is also white. This is lead 2 nitrate, which is also white. So those are the physical appearance of the substances. Let's move to another slide. What happens next is this next subtopic, action of heat. So we are seeing certain test or a command. They are saying heat a sample of the substance in a dry test tube. In each case, state any gases or gases which can be evolved. So you're going to say, the table is just illustrating. If you see this, how do you deduct? Now the first observation is a yellow solid when hot, which turns white on cooling. That is zinc oxide. But within zinc oxide, you're having zinc 2 ions. That's what we suspect. Next is a brown solid when hot, which turns zero on cooling. That is lead 2 oxide, and lead 2 ions probably present. We don't mind about the oxygen. We just need the cations. A black solid residue. That is copper 2 oxide. And you say copper 2 suspected present. Colorless gas that turns zyme water milky. You first talk of what is that gas. That is carbon dioxide. Then after, which anions or which ions bring about that gas? It is carbonate ions and hydrogen carbonate ions. So we are seeing someone who has observed the colorless liquid at the upper cooler parts of the test tube. So you see, when you heat substances and at the upper cooler parts of the test tube, you see some small liquid which is like a sweat. So that means the substance which you have heated has somewhat of crystallization. And there we can say the substance is a hydrated compound. A colorless gas that has an irritating choking smell. The gas is ammonia gas, and ammonium ions suspected present. A reddish browny gas, let me try to move it up. a reddish browny gas that turns damp litmus paper red. The gas is nitrogen dioxide gas and nitrate ions present. Let's move to the next slide. So this video is illustrating what happens when you heat.
First, I will show you that action on heat. That means what happens when we heat certain chemicals. First one, that zinc carbonate. Now zinc carbonate is that white amorphous solid. Zinc carbonate is white amorphous solid. Now on heating, what happens? Now it will produce carbon dioxide, that colorless, odorless gas. When we pass through that lime water, it turn milky, and that residue, that one zinc oxide. Now zinc oxide in cool condition white and in hot condition yellow. So see, we heat that zinc carbonate. See that CO2 is equal, we pass that CO2 through that lime water. See that lime water turn milky when we pass that CO2, and you see the residue, that yellow color, because it is now in hot condition. So that zinc oxide, now hot condition, that yellow color residue. See that yellow color residue of zinc oxide on hot condition, and when we keep it, it again become white. That one lead nitrate. Lead nitrate on heating, it convert into lead oxide, that one yellow.
So that's it. The video continues to explain what happens on heating. Let me move to the next slide. Action of the reagents on the substances. The commonly used reagents are sodium hydroxide and ammonia solution for the cations. What do you do? To the solution, add the reagent dropwise until in excess. I'm having two tables. One is representing the action of sodium hydroxide solution. The reagent is sodium hydroxide solution. Another one is action of ammonia solution. So let me first deal with this. Whenever you see something like white precipitate soluble in excess to form a colorless solution, as in when you added the reagent, you first form the precipitate. As you added the reagent in excess, the white precipitate disappeared to form a colorless solution. So what you suspected is zinc, aluminium, or lead. Next, if you see white precipitate insoluble in excess, that is magnesium, which is so it is magnesium which is suspected present. Now, if you see blue precipitate insoluble, whenever you see a blue, you suspect copper. Green precipitate, that is iron. Blue precipitate, that is iron 3, not blue, brown. So let me try to move this up. If you see colorless gas with a choking smell, colorless gas with a choking smell, that gas you just confirm ammonia. Let me move to action of ammonia solution. Whenever you see white precipitate is soluble in excess to form a colorless solution, remember when we added sodium hydroxide, we saw the same thing. We deducted zinc, aluminium, and lead. For this time, when you have white precipitate soluble in excess to form a colorless solution, you confirm zinc, because zinc is the only ion which does the same, which brings the same observation in both of the two reagents. If you see white precipitate insoluble, that is magnesium, aluminium, and lead. Blue precipitate soluble in excess to form a deep blue solution, you form copper 2, confirm the present. Green precipitate insoluble, iron 2. Brown precipitate, iron 3. If you see no change, that is calcium. Next slide. Video for the action of sodium hydroxide.
Everyone, today I'll be testing for cations using sodium hydroxide. I'll now display the different tests that we'll be doing on the screen. The first test that we'll be doing will be with iron 2 and sodium hydroxide. Iron 2 is actually a pale green solution. That's iron 2 sulfate right there. So it's actually a pale green solution, and I've gone ahead now to measure out 2 cm cubes of it so I can carry out my test so you can know what 2 cm cubes look like. So we have 2 cm cubes of solution in the test tube. Remember, it's pale green. I'm now going to add sodium hydroxide solution to it. Mix it thoroughly. And we've seen the formation of an olive green precipitate.
So you're seeing pale green precipitate. So the video continues to explain. Now I'm moving to the video for action of ammonia solution. So those are calcium ions. You get ammonia solution, they add more. So you see white cloudy precipitate formed in excess. So when they move to lead, they lead it to ions. So when you add ammonia solution, we're going to form what you replace with icing, like it has formed a precipitate down. When you add excess ammonia solution, it forms like precipitate. So let's see zinc. Let me stop with the zinc. Put there, you're going to form that's white precipitate, but you see this precipitate is soluble in excess. It has formed the precipitate and the precipitate has disappeared. So let me stop there. The video will continue from there. So let's move to the confirmatory tests. After knowing how they react with those reagents, how do you confirm that this is lead? We have seen zinc can be confirmed by just action of ammonia solution. Leading to ions, we use a reagent which is potassium iodide. Confirmatory test must give a unique observation. When we get potassium iodide, we add it to anything which is suspect to be having lead to ions, you're going to see yellow precipitate. Immediately after seeing this yellow precipitate, you just confirm that there exists lead to ions. Zinc 2 ions are confirmed by ammonia solution, whereby you form white precipitate soluble in excess to form a colorless solution, as we've seen from the video. Copper 2 ions, they are confirmed also by ammonia solution, whereby we saw a blue precipitate soluble in excess to form a deep blue solution. This is the video for confirmatory test.
Done experiment 6.10 to confirm the test for cation, but certain cation only using two reagents, so they have hydroxide and ammonium aqueous. So we confirm only using two reagents, so they have hydroxide and ammonium aqueous. So we have to proceed with experiment 6.11 to confirm the presence of certain cation, especially ammonium ion, iron 2 ion, iron 3 ion, and electron ion in aqueous solution. Ammonium nitrate containing ammonium ion, cation is ammonium ion, and then you add Nestle reagent. Brown precipitate is formed. Lead 2 ion.
You're seeing little ions confirmed by potassium iodide.
Lead 2 ion, colorless lead 2 ion, and then add potassium iodide.
So that is the yellow precipitate which is formed. Now let me stop there for time being and I move to the anions. How do you confirm anions? The sulfate ions. The reagent which is used is called the dilute nitric acid followed by barium nitrate solution. As we saw previously when we were studying acids, bases and salts, we saw like all sulfates are soluble apart from barium, lead, and calcium, which is sparingly soluble. So those three ions which form negative tests are the ones which are used to confirm. So here we are going to use the nitric acid followed by barium nitrate. Our target is to form barium sulfate, which is insoluble. That's the white precipitate. We confirm sulfates. Next is carbonate ions. Carbonates are confirmed by reagent, which is simple. We just get any dilute amino acid, we add it to anything which you suspect to be having carbonates. There is going to be bubbles of colorless gas coming from the solution. Those bubbles of colorless gas, they are showing the existence of carbon dioxide gas. Chloride ions. The reagents which is going to be used, we can use nitric acid followed by silver nitrate solution. In fact, it's the same case as sulfate ions. All chlorides are soluble apart from lead and silver. So we use silver because it is unique. When you use lead, lead is common with sulfates and chlorides. That means when you form white precipitate, when you have used the lead, so it will make you to suspect whether it is zinc, whether it is sulfates or chlorides, because lead is insoluble in both. So that's why we decided to use silver nitrate solution. The observation is white precipitate. Nitrate ions. The reagent to be used, we are going to use freshly prepared iron sulfate, which we add in the test tube where we suspect to be having nitrate ions. So we hold the test tube in a slanting position and we add drops of concentrated sulfuric acid. We see the brown ring. This is the video evidence.
Qualitative analysis of anions.
So those are type of warnings whereby students are not supposed. Remember when you were still in
This
senior
video
one,
clip demonstrates
so
how
you
to
not
identify
to go in the laboratory without teachers' consent, because some things are very dangerous. As you've seen somewhere saying concentrated sulfuric acid, so you should not play with those acids.
anions. To analyze what anion is in the sample, we can add the appropriate reagents and observe the chemical changes. The following parts demonstrate the testing methods for common anions and the expected observations. Chloride ion.
The conformances for
Halide
chlorine
ions
ions.
can be identified by silver nitrate solution. Add silver nitrate solution to a solution containing chloride ion. A white precipitate is formed. The white precipitate is silver chloride. It is insoluble in water.
So that is it. The white precipitate is of silver chloride, which is insoluble in water. So that has marked the end of our topic with the videos. Now, these are the reasons for why I selected those visual materials. In subtopic 1, I used images in order for my students to see and differentiate the physical appearance of the cations in the topic. Since my learners are able to see properly, I know they can recall all the colors if asked by someone. Since they can remember the pictures minus them being moved, as it could be when we have used the video. In the next subtopics, subtopic 2, 3, and 4, I've used mostly videos. These videos have been helping my learners to see how everything is made, as we have been seeing. So that has marked the end of my project. I take this opportunity to thank my Doctor of Education Technology, Dr. Bernadette. Thank you, Madam.